This videotape deals with addition and subtraction of rational expressions. Rational expressions are just another term for an algebraic fraction. Okay, the basic idea when adding fractions, if you have, say, a over c plus b over c, is that you have to have the same denominator. When you have the same denominator, you can add the numerators and place it over the common denominator. And it's also good for subtraction. Okay, a minus b over c. This would be a minus b divided by c. Okay, so for either addition or subtraction, you have the same denominator. Okay, you combine the numerators and put them over the common denominator. Let's try some examples. By the way, this is going to be going rather quickly over the basics. If you'd like to see a slower videotape on these topics, I would suggest you refer to the appropriate elementary algebra tapes. Okay, 3x plus 7 over 2x minus 4 plus 5x minus 7 over 2x minus 4. Two fractions with the same denominator. So we're going to combine the numerators, 3x plus 7 plus 5x minus 7, all over 2x minus 4. Now, combining like terms in the numerator, we get 8x, 3x, and 5x. The plus 7 and the minus 7, that just gives you 0, over 2x minus 4. Now, in all of our work with fractions, we will consider our problem to be completed if our answer is in lowest terms. That is, we don't want there to be any factors in common in the numerator and the denominator. We notice, however, here that 2 is a factor in the denominator. We can rewrite the denominator as 2 times x minus 2. 2 is also a factor in the numerator. Okay, the numerator is 2 times 4x. So we can divide numerator and denominator by 2 using the fundamental principle of fractions. Okay, that is, you can divide numerator and denominator of a fraction by the same non-zero quantity and get an equivalent fraction. This gives us a final answer of 4x over x minus 2. And don't get ambitious here or try to improve on this answer. You cannot cancel anything else. The x's do not cancel. X is a factor on the top but not on the bottom. And the 2's don't cancel. The 2 does not cancel into the 4. 2 is not a factor in the denominator. Just 4x over x minus 2. Okay, let's try another example. 7x minus 5 over 3x plus 9 minus, now this fraction, 6x minus 4 over 3x plus 9 plus 4 over 3x plus 9. Okay, now all of these fractions have the same denominator, so we're just going to combine the numerators. Now, when you're just working with addition, you didn't have to be that careful. Okay, it's really that we're adding, say, this numerator and this numerator and putting them over the same denominator, but the parentheses could have been left out. With the plus sign, it didn't really matter. With subtraction, however, it matters very much. Okay, so it's a good idea to put the parentheses in, especially if you have subtractions. You must. These all have the same denominator, so we're going to combine numerators over that common denominator. We have 7x minus 5, take away this numerator, 6x minus 4, plus 4. The minus sign here is very important because what you're subtracting has more than one term, which means this minus sign must be distributed through those terms. This is 7x minus 5. This is really like a minus 1 here, which is to be sent through the parentheses in the multiplication. Minus 1 times 6x gives us minus 6x. Minus 1 times minus 4, that's plus 4. And now another plus 4. Over 3x plus 9. Let's combine like terms in the numerator. 7x and minus 6x, that gives us plus 1x. Minus 5 plus 8, that gives us plus 3. X plus 3 over 3x plus 9. Okay, now, you can cancel the x's, but What you can do is factor the denominator, and if you do that, you will see that we don't have lowest terms yet. The denominator can be rewritten as 3 times x plus 3. And we can cancel the 3's. Okay, when we're canceling the 3's means dividing numerator and denominator by x plus 3. X plus 3 divided by x plus 3 is 1. X plus 3 divided by x plus 3 is 1, for an answer of 1/3. Okay, if you were just to cancel the x plus 3, that's perfectly okay, but remember, there's really a 1 implied on the top. The top doesn't disappear. If you were dividing, you were left with a 1. So the answer is 1/3, 1/3. Okay, now that's fine if you happen to have the same denominators in all the fractions that you're adding or subtracting. Now let's look at an example in which the denominators are different. 3/8 minus 1/18 minus 7/30. We can't just say, combine the numerators and put them over the same denominator because we don't have a common denominator here yet. Okay, now remember the fundamental principle of fractions, which says you can take a fraction, divide numerator and denominator by same non-zero quantity, and get an equivalent fraction. Okay, this is assuming b and k are not 0. This is the fundamental principle of fractions. You've seen this many times. Okay, now in the last videotape on multiplication and division of fractions, and also earlier in this tape when we wanted to reduce to lowest terms, for example, in this problem we divided numerator and denominator by 2. Here we divided numerator and denominator by x plus 3. We divide numerator and denominator by the same non-zero quantity, and we get an equivalent fraction. Okay, used in this way, it's called reducing the fraction. In this videotape, we're also going to want to use this relationship in the reverse order. This is called building fractions. In other words, we want to start with a fraction and then multiply numerator and denominator by the same non-zero quantity and get an equivalent fraction. Whereas what we're looking to do is build fractions equivalent to the fractions that we have in this problem. They'll have larger denominators. Okay, we want to build fractions equivalent to these that all have the same denominator. Okay, what we're going to look for is, say, the smallest number so that 8 goes into it evenly, 18 goes into it evenly, that is no remainder, and 30 goes into it evenly. And then we're going to build fractions equivalent to these, all have the same denominator, and then, once they have the same denominator, we can combine the numerators. Okay, now, what we need to do is to find the least common denominator, the smallest denominator, so that all of these denominators divide evenly into it. Okay, sometimes we call this the least common multiple of these numbers, 8, 18, and 30. So either way, the least common denominator or the least common multiple of these denominators. Okay, and let me give you a procedure for doing that. To find the LCD, or LCM, least common denominator or least common multiple. First of all, factor each denominator completely. And then take each factor the greatest number of times it appears in any one denominator. Okay, let's look at the problem that we have over here. Okay, we have 3 denominators. This is to find the LCD. Okay, first of all, we'll take our 3 denominators, 8, 18, and 30, and factor each denominator completely. Okay, for constants, it means taking it down to prime factors. 8 can be written as 2 times 4, but then 4 can be written as 2 times 2. So we have 2 times 2 times 2, a prime factorization of 8. 18 is 2 times 9, but 9 is then 3 times 3. And finally, 30 is 2 times 15, and 15 is then 3 times 5. To find the least common denominator, we're going to take each factor the greatest number of times it appears in any one denominator. There are 3 types of factors here. There are 2s, 3s, and 5s. Okay, our LCD will be composed of 2s, 3s, and 5s. Now, how many 2s to take? You don't say 1, 2, 3, 4, 5. There are 5 2s, so you take 2 5 times. You look in any one denominator, what's the greatest number of times it appears? Here 2 appears 3 times, here once, so you take 2 3 times. 3 times, 1 time, 1 time for 2. We take it the greatest number of times it appears in any one denominator. So we take it the 3 times. Now let's look at 3. Here it appears 0 times, here 2 times, here 1 time. We take it the 2 times. 5 appears no times, 1 time, so we take it the 1 time. And we see then the LCD is 2 times 2, 4 times 2, 8. Okay, 8 times 9, 72, times 5 for 360. That is the smallest number, so that 8, 18, and 30 all go into it evenly. Okay, now what you could do, a common denominator, although usually not the least common denominator, is a product of the denominator. Certainly, 8 times 18 times 30 is a number so that 8, 18, and 30 all divide into it. Okay, generally, it's much larger than you need. In this case, certainly it would be. Okay, so we're trying for the least common denominator. Okay, now let me show you what to do. You have found your least common denominator. We are now going to build fractions using the fundamental principle of fractions, build fractions equivalent to these fractions that have the same denominator. And we're trying to add 3/8 minus 1/18 minus 7/30. I am looking to build fractions equivalent to these, all having denominator 360, which I know I can do. Okay, and remember, if you're going to do something to a denominator, you have to do the same thing to a numerator. Whatever you multiply the denominator by, you must also multiply the numerator to get an equivalent fraction. The first thing you do is you say, how do I go from 8 to 360? 8 times what gives me 360? So you can go actually take 8 into 360 and get 45, or some people prefer to look at the LCD, which is a factored form of 360, and say, look, 8 is 2 times 2 times 2. 8 times this must be 360. This is 9 times 5, 45. So either take part of the LCD and do it that way, or straight off go 8 into 360 and see that this was found by multiplying by 45. This was multiplication by 45. So if you're going to multiply the bottom by 45, you must multiply the top by 45 as well. That's the fundamental principle of fractions. Okay, you can get an equivalent fraction if you multiply the top and the bottom by the same non-zero quantity. Okay, let's look at the next one. We want to go from 18 to 360. That's done by multiplying by 20. If you multiply the denominator by 20, you must multiply the numerator by 20 as well. And finally, to go from 30 to 360, that's done by multiplication by 12. If you're going to multiply the denominator by 12, you're going to multiply the numerator by 12 as well to get an equivalent fraction. Now you have 3 fractions equivalent to these, all having the same denominator. By the way, you do not now say, I'll reduce to lowest terms. You'll just go back to where you started. Instead, you're going to keep this. I realize that these fractions are not in lowest terms, but that's exactly the point. They all at least have the same denominator. We combine now the numerators over this least common denominator. 3 times 45 minus 1 times 20 minus 7 times 12. That gives me 135 minus 20 minus 84 all over 360. 135 minus 104 over 360 for a final answer of 31 over 360, which is in lowest terms. Okay, let's try some more examples. Okay, what I want to do before we actually work out some more problems with adding fractions is to just look at denominators. I'll just give you denominators. We want to find the least common denominator or the least common multiple. Find the least common multiple. And the things we're looking at are 4x squared y, 10xy cubed, 5xy squared. You have you wanted to add fractions, okay? And these are the 3 denominators. I'm not going to do a specific problem. Just practice in finding the LCD or the LCM. The trick is to factor each denominator completely. Okay, with constants, I want to go down to the prime factors. So 4 is 2 times 2. X squared, that's x times x, and then y. 10 is 2 times 5, x, and then y cubed, which is y times y times y. 5 is 5. This is x, y, y. The least common multiple, take each factor, the greatest number of times it appears in any one denominator. Okay, on the numbers we have 2's and 5's. We have 2 2's, 1 2, no 2, so we have to take 2 twice. No 5's, 1 5, 1 5, we'll take 5 once. 2 x's, 1x, 1x, so we will take x twice. 1 y, 3 y's, 2 y's, we will have to take y 3 times. So the least common multiple would be 4 times 5, 20, x squared, y cubed. And if you were adding fractions with these denominators, you would be combining all fractions over that denominator, the least common denominator, 20x squared, y cubed. Let's try another one, and then we'll do some more examples. Okay, find the least common multiple. And we're dealing with x squared plus 4x. X squared plus 5x plus 4, and 2x. To factor each denominator completely, or each of these expressions completely. The top one, we look for a common factor. We have x. It's x times x plus 4. We always start by looking for a common factor. X squared plus 5x plus 4, however, has no common factor, but we can use our rules for factoring a trinomial with lead coefficient 1. That is, we're looking for 2 numbers which multiply to plus 4 and add 2 plus 5. That's plus 4 and plus 1 here. X plus 4 times x plus 1. And finally, 2x is just 2 times x. That's already factored. And to get the LCM, take each factor, the greatest number of times it appears in any one of these expressions. The only number here is 2. No times, 1 time, so we'll take it. X occurs once, no times, 1 time. We'll take it, 1 time. X plus 4 occurs once, x plus 4 occurs once, x plus 4 occurs no times, so we will take the x plus 4 once. X plus 1 occurs no times, 1 time, no times, we will take the x plus 1. Okay, so the least common multiple is 2 times x plus 4 times x plus 1. Okay, let's try another problem where we add fractions. 3 over 2x cubed plus 5 over 3x squared y plus 4 over 5y squared. We want to find the least common denominator for those denominators. By the way, you can try this on your own. Shut the machine off and then turn it back on when you finish to see how you've done. First, we're going to have to find the LCD for the 2x cubed, 3x squared y, and 5y squared. We'll factor everything as far down as it goes. 2x cubed is 2x, x, x. 3x squared y, 3x, x, y. 5y squared, 5 times y times y. The LCD, we take each factor, the largest number of times it appears in any one denominator. The 2 occurs once, no time, so put it down once. 3 occurs no times, 1 time, no times, we put it down the 1 time. 5, no times, 1 time, we put it down the 1 time. X, 3 times, 2 times, no time, we put it down the 3 times. Y, no times, 1 time, 2 times, we put it down the 2 times, the largest number of times it appears in any one denominator. Okay, 2 times 3 times 5, that's 30. X cubed y squared for the least common denominator. Once we found that, we are going to build fractions equivalent to these fractions, all having this least common denominator, 30x cubed y squared. That's the smallest algebraic expression. So all of those denominators divide evenly into it. Okay. Just like we did in the problem with the numbers, ask yourself what you would have to multiply this denominator by to get that denominator. And whatever you do to that, whatever you'd multiply that denominator, you multiply the numerator as well. Okay. To go from 2 to 30, you multiplied by 15. To go from x cubed to x cubed, you didn't have to multiply by anything. To go from 1 to y squared, you'd have to multiply by y squared. In other words, 2x cubed times the 15y squared would give you the 30x cubed y squared. Since you multiply the bottom by 15y squared, you must multiply the top by it as well. The same thing here. Ask yourself, what did you multiply this denominator by to get that? And you multiply the numerator by the same quantity. To go from 3 to 30, you multiply by 10. From x squared to x cubed, you multiply by x. From y to y squared, you multiply by y. You multiply the bottom by 10xy, you multiply the top by 10xy as well. And finally here, to go from 5 to 30, you'd have to multiply by 6. To go from 1 to x cubed, you'd multiply by x cubed. To go from y squared to y squared, you just multiply by 1. So you'd have to multiply top and bottom by 6x cubed. Now, All of these fractions are equivalent to the ones that we started with, and yet they have the same denominators, so we can combine numerators over the common denominator. We have 3 times 15y squared. That's 45y squared. 5 times 10xy, that's 50xy. 4 times 6x cubed, 24x cubed. And this is the answer, and it's in lowest terms. Okay, let's try another example. 5 over x squared plus 2x plus 2 over x squared minus 4. Let's find the LCD for x squared plus 2x and x squared minus 4. The trick is to factor these denominators completely. X squared plus 2x is factored by taking out the common factor of x, leaving you with x plus 2. There is no common factor in x squared minus 4, but the difference in two squares can be factored x plus 2 times x minus 2. The LCD there, let's see, the factor x occurs one time here, no times here, we take it the one time. X plus 2 occurs once here, we take it once. X minus 2 occurs no times, one time, we take it. That's the LCD. Okay, so we're going to, and it might be helpful to write this in this form now. So we see what we have here. Okay, those are the two denominators. Now we're going to combine over the LCD, which is x times x plus 2 times x minus 2. X times x plus 2 times x minus 2. You look at this denominator, you say, what did you do to this denominator to get that one? What did you multiply by? You multiplied by x minus 2. Therefore, you must multiply the top by x minus 2 as well. To go from x times x plus 2 to x times x plus 2, x minus 2, you multiply the bottom by x minus 2, you multiply the top as well. Similarly, this denominator, x plus 2 times x minus 2, to get this one, x times x plus 2 times x minus 2, you multiply the bottom by x, you multiply the top by x as well. Giving us now two fractions, same denominator. We combine numerators over that common denominator, which is x, x plus 2, x minus 2. We have 5 times x minus 2 plus 2x. This is 5x minus 10 plus 2x. I distributed the 5 through the parentheses, and then add the 2x. 5x plus 2x gives us 7x. 7x minus 10 on top. X times x plus 2 times x minus 2 on the bottom. This answer is in lowest terms. By the way, if you want to, having seen that there are no factors in common, if you wanted to multiply the denominator back out, okay, you could. Okay, sometimes when you look like in the back of the book for an answer, you'll see it in this form. Other times you'll see it multiplied. It doesn't matter. The factored form has the advantage here of enabling you to see that there are no factors in common. Okay, let's try one more example. Five over x squared minus x minus 6. Take away 2 over x squared minus 4x plus 3. So let's find the LCDs. We have two denominators, x squared minus x minus 6 x squared minus 4x plus 3. Neither one of these has any factors that you can pull out in front, but they are trinomials with leaf coefficients 1, and we can factor in the following way. Here I want two numbers which multiply to minus 6 and add to minus 1. Okay, that would be a minus 3 and a plus 2. X minus 3 times x plus 2. Checking by FOIL, x squared plus 2x minus 3x gives me the minus x minus 6. And here, two numbers which multiply to plus 3 and add to minus 4. That's minus 3 and minus 1. And when you check by FOIL, you get x squared minus 4x plus 3. The LCD, the factor x minus 3 occurs once. Once, we'll take it. Once. X plus 2 occurs once, no times. We take it the once. X minus 1, no times. One time, we take it once. X minus 3 times x plus 2 times x minus 1 for the LCD. Let me just rewrite this in the factored form. We're going to build fractions equivalent to the ones that we have, but they should have common denominator. The common denominator is x minus 3 times x plus 2 times x minus 1. Okay, and as always, we ask ourselves, what did you multiply this denominator by to get this one? And whatever you did, you're going to multiply the top by the same thing. To go from this denominator to this one, I multiplied the denominator by x minus 1, so I must multiply the numerator by x minus 1 as well. Similarly, over here, to go from this denominator to that one, I had to multiply the denominator by x plus 2, so I multiply the numerator by x plus 2 as well. Now I have two fractions with the same denominator. I combine the numerators, and be careful, because it's a subtraction problem, so you're going to have to be careful when you distribute this minus 2 through the parentheses here. Okay, we get 5x minus 5 minus 2x minus 4. Here we distributed a 5, here we distributed a minus 2 over x minus 3, x plus 2, x minus 1. On top we have 3x minus 9. On the bottom, x minus 3, x plus 2, x minus 1. And we're not finished yet. Let's continue it up here. We've gotten as far as 3x minus 9 over x minus 3 times x plus 2 times x minus 1. This is not in lowest terms, because if we factor a 3 out in the numerator, we notice that x minus 3 is then a factor in the top and the bottom. We can divide numerator and denominator by x minus 3, giving us the final answer, 3 over x plus 2 times x minus 1. And that brings us to the end of the tape.